Hello, this will be a follow-up to the video I posted yesterday in regards to the Parthenon, and it's while I was looking stuff up I come across this particular paper and Bulken's analysis of the proportions of its Parthenon and its meaning. Now when I try to open I can't post the link because it will ask you directly to open, it will go directly basically open it with Microsoft Word or one of those types of documents. So if you do a search, you can just search that term and it will pull up the link. But now if I bring it... Okay, so Anne Bulken's analysis of proportions of its Parthenon and its meaning. And basically she's talking about the musical proportions which are based in there, and also in regards to the measuring systems. It's also worth noting that it was as many of these older temples were also treasury buildings. So the Delian League, this was if we go there, so it was served as a treasury for the Delian League. And then she goes into how the width and length and proportion of height to width is this 4:9 ratio, which was mentioned in the video I posted yesterday, Secrets of the Parthenon. But also interesting, very, very interesting, is because I've seen it, I have to pull up the Paestum complex of temples, for instance, in Italy, one of the Greek colonies there, the use of Pythagorean triangles in the format. Now, it's something I remember looking at a long time ago, but Pythagorean triangles, Paestum complex, if you're interested in doing a search. But here she talks about musical proportions, and especially the perfect fifth, or 3/2, and how this relates to 9/4. Now, while I'm here, I might as well point out there's a lot of other stuff in regards to now, for instance, I'll just reduce this a little bit. Okay, so what's very interesting is that modern scales of measure correspond directly to ancient scales of measure, and for instance 4:3 and 16:9. Now that's just one example, and if I bring up now, if you go to the Greco-Roman weight scales and how they compare in grains, now you'll notice these again. Now this chart is very important, these most harmonic numbers, and how well, it's just, you can't make it up. It's even how it converts in the metric system, but that's something else for the moment. Now back to now, it's interesting read. Again, you can search for the link, but she's talking about 9:6 and the 9:4, and how this corresponds to 9:6, ultimately bringing us to perfect fifths of 3:2. And music was at the core of the Pythagorean schools at the time. Now, also she points in regards to the proportions of the temple, so the inner temple, the entire temple, in how they relate to, so the base proportions, but also how they relate to the columns and height, for instance. And this particular set of numbers, now D or dactyl, is the equivalent of a finger. So 1 foot is, as we know it, is made of 16 fingers, which you can just rewrite as dactyl, sort of, or digits isn't maybe another way to consider it. But all these numbers is just, again, quite extraordinary. And again, these can be measured. It's there in the writing. It's not at all contentious that the Pythagorean schools and their interest in music and how it relates to geometric proportions. Can't remember the person who said it, but for instance, the saying, geometry is music frozen in time, and all these things just lead and blend back into one another. Now, okay, so with a focus to begin with on these numbers to begin with. Okay, well, before I go there, also she talks about Pythagorean triangles. So we have the Pythagorean Theorem, a squared plus b squared equals c squared, And of the Pythagorean triplets, the first is the 3-4-5 triangle, famously used even by the ancient Egyptians. But the second is the 5-12-13 triangle, and how these proportions are, well, cleverly sectioned into two rooms at a later stage of the design. Thus, there may be layers of geometric implication not immediately visible to the eye, and well, I couldn't say it better, how secrets in plain sight. These guys and girls were incredibly clever, and they understood this concept of harmony, and it's just sort of, it's so it's become the antithesis of our so-called modern rationalism, because of the implications, and it's just like, don't talk about it. This is all superstition of the ages, yet it's measurable. These proportions are fundamental still in this state in regards to geometry. Okay, while I'm here, I might as well point out, so that Pythagorean chart, most harmonic numbers, so there we have musical scales there, and how it can Pythagorean tuning. And well, okay, so if you're watching this on a screen, even screen resolution, so as you can see here, full HD, this is being carried through. The beauty of these numbers is still embedded with us today. It's in modern systems, including radio, for Greco-Roman weights, even with apothecaries, and how they will just coincidentally happen to beautifully convert to all these beautiful numbers, and including via the metric system and the troy ounce. So when you see the price of gold quoted, they're not talking about the food ounce. The troy ounce is separate from, it's used to weigh precious metals. Bode's law, time. So, for instance, 24 hours a day, 60 minutes, 1440 minutes per day, 86,400 seconds per day, 360 seconds per hour. The compass, how it's divided, the divisions of the compass, 360 degrees, which is each degree 60 minutes. Each minute of the compass is 60 seconds. Again, Mayan calendar, the Pythagorean tuning, the Platonic solids, precession of the great year, precession of the equinoxes, again TV screen resolution, just a small sample of Earth, Sun and Moon across multiple scales of ancient measure, including the so-called modern mile, but it extends, just a small sample. Another one, the yugas, I even have a yugas breakdown. Again, cross cultures, across time. It's not just from across the Silk Road. It actually you can find it in Mesoamerican cultures. Also, the legends connected with them, and the fundamental unit of sacred geometry is the vestica. You can create 90-degree angles, all that type of stuff, and the breakdown of those degrees, which is essentially also the hexagon. It's all in there. Another example of screen resolution. All of the way geometry and based on the 360-degree compass, hexagons, and yeah, it's even here in Australia, for instance, our radio AM, our FM goes up to 180, but the AM is divided into units of 9, which again delivers us this particular system. Australia, founded on Hermeticism, and we'll go into that shortly. Okay, so yeah, just a quick sample there. Now back to this particular article and the 3-4-5 triangles, and by that I mean, so for instance, Governor Macquarie arrived in Australia in 1810, immediately set about pretty much the equivalent of George Washington here in Australia, very much into survey, a conscientious Freemason, not just like a social club member, but like literally into the craft. And when he did arrive, he set up a bunch of new towns, especially the 5 new towns of, as written, Richmond, Castlereagh, Pitt Town, Windsor, and which one I'm forgetting to mention. One of them there is actually 5 towns, but 4 of those 5 towns, for instance, Richmond was based on this 8 by 12 chain design, which brings us, it's a series of interlocking 3, 4, 5 triangles, while Windsor, which is, for some other reasons, is marked out as the capital of this little province north of Sydney, is at a 5 to 12 ratio, bringing us to interlocked 5, 12, 13 triangles, which is exactly the same as described in the article here as paired triangles of 5, 12, 13. Exactly the same things going on. Now, so 5, 3, 4, 5 triangles. Okay, we'll get to this, for instance, here, how the area of this particular set of 3, 4, 5 triangles brings us to 777,600 square dactyls. And where to next? So again, music, and okay, I'll do it in okay, so I'll do, now haven't shown it, I'll do it in no particular. Okay, before I do go there, the 3, 4, 5 triangles used in the design by Governor Macquarie, even the measures he set up at these very lovely numbers, which will correspond to. So if you, for instance, if we go to back to this chart, and you'll find, for instance, these numbers here are based on 81, so 81, 162, 324, etc., as where these are based on 27. However, this particular system is based on 33. Now, by that I mean if you keep reducing, so 528 divided by 2 divided by 2 divided by 2 will come back to 33. Another example is the 66 feet. The underlying number, I just because I haven't seen a term for it, so I just call it the Masonic Scale based on 33. Just keep dividing it up, and that will bring us directly to, well, this exact same type of info as I'm showing here. Harmony points between Earth, Sun and Moon, precession, all these other information is carried in there. Okay, and next, okay, I just have to pause a moment. Okay, so also what's worth noting is this, that they mentioned the Tetractys based on powers of 10, and Pythagorean number theory, music, cosmology, and arithmetic, geometry, astronomy, and music, and well, again, these all sort of come back to one another. And 3, 4, 5 triangles, 5, 12, 13 triangle, and this 2/3 ratio, which is the perfect fifth. Now, if we bring up, okay, so as an example, if we let me pull something up. Okay, so the perfect fifth is 2/3 ratio. So as again, we'll come back to this Pythagorean or harmonic number chart. And as an example, that's Frank Albo's done some work in regards to focusing on Winnipeg. Even the building itself, which has a whispering chamber, all these elements in it, but it's at a 2/3 ratio, also called the Hermetic constant. And Hermeticism, just, well, it's Hermetic. But that also corresponds with the street plans here by Governor Macquarie, based on the vesica with the 3, 4, 5 interlocking triangles. Here we have 4, the Parthenon has 6, but using, again, build off the vesica, this fundamental, which has all those degrees and the numbers, which again correspond with that chart. At 8 to 12 chains, it's 2/3. It has this constant, and you'll find it in many other street plans of places around the world, especially with very strong connections to Freemasonic traditions. The Ionic, the Doric, Corinthian column, for instance, in tracing boards, it's built into that particular method. So next, where are we now? Okay, so I'll try and start at the base, at the beginning. Now, for instance, in the article, that paper, they're talking about the various ratios. for instance, with a focus on this particular section here and how those other proportions and how they all connect, and they're built at specific measurements which will deliver us very specific integers, whole numbers. And if we have a look at, give me a moment. Okay, so begin here with 24 modules or 96 dactyls, which is connects two fingers. So here we see the chart 24 and 96. Okay, I'm getting ahead of myself because she mentioned the tetractys, and that's, let's just see, series of 4 dots. Now, even this will music theory connects to it, but you will find it in, well, architecture, symbolism, and other parts connected to even Kabbalist tradition in the Tetragrammaton, which of the name of God, which even Hermeticists such as Athanasius Kircher, all of them really. And again, this is just a standard symbol, many connections, but which it's the same. It's the tetractys. And interesting thing in, well, it's quite a bit. This might seem simple, just these, triangle made up of 10 dots. So if we add them all to multiply those, we get 24. If we add them together, we get 10. But in the third dimension, so if we 1 cube plus 2 cube plus 3 cube plus 4 cube, we get 100, and that's a key. There's this a 4D based built around binomial theorem. The connections back to these harmonic numbers is just extraordinary. I've done a video on it. Binomial theorem's pretty nice, but if you do it in this sort of 4D matrix, and then you vertical, horizontal, diagonal lines, every single time, it brings us to these very lovely, perfect harmonic numbers. Now back to, so the tetractys or the tetragrammaton, again, one of the, it's in Freemasonic rituals as well. So now, more over the width of the cellar or the inner temple inside the Parthenon, 24 modules or 960 dactyls. Now, so we have 24 from the tetractys in the chart as well, and even 96. So 96 is 900 and is not 960. It's 1/10 of that, but that in itself is encoded in the tetractys. These powers. Now, base 10 is quite old. Now, Leo Fibonacci, not only the Fibonacci numbers, he repopularized Hindu Arabic numbers, but there's a lot of base 10. You can see it in a lot of other places. But for instance, that's the beginning. Now, I'll probably jump too far ahead. Okay, and also she talks, well, pentatonic tuning. So here's an example: 54, 64, 72, 81, 96, 108. And let me try and find, okay, so if we begin with showing that one, okay, if we extend those numbers, okay, I'll go through them. They're not set in order, but you'll get the meaning. So likewise, the length of a cellar, 54 modules, 2,160. The diameter of a moon, 2,160 miles. The cube is platonic solid, made up of 2,160 degrees. But also, for instance, again, once more, this 10:1 ratio, bringing us to 54:16. stylobate width, 36 nodules. Stylobate length, 81 nodules, 3240. Again, in there, this same ratio. Also mentions 6 3-4-5 triangles covering the stylobate have an area of 770,600 square dactyls. Again, you'll find it there, and it's again at a power of 1 to 100. Comes from the tetractys in the third dimension. The perfect fifth, 2 to 3. Now, dimensions of the inner and outer structure give rise to a succession of lengths corresponding to 4 successive musical fifths: 81, 54, 36, 24, 16. Again, the musical fifth. 2 to 3 as an example from the Tractus. 3 to 4 is the perfect fourth, and this all built in. Again, the same sets of numbers. They reinforce one another. They don't just appear twice, they appear many times. Even the ratio of 9 to 4 for length to width and width to height, 9 to 4, it's in there. The width of the cellar inner temples, covered that one, that's 24 and 96. Okay, so geometric mean 16, 640, 36, 14, 40, and once more, just again, powers of 10. We saw those. And well, again, okay, I'll just flick through them. You see what I mean? That we have the same pattern now. This is exactly the same pattern, exactly the same set of numbers that reappear in the US Capitol building, all the state capitals, major cathedrals across the world, going back to the great cathedrals such as Beauvais, Chartres, all of them, Sanchi Stupa, all these stupas across India. Back, it's just always in there, always repeated, and again. To call it coincidence is a faith-based dogma is the only way I can think of it, and it's just the system has just been passed on. Music, geometry, arithmetic, and astronomy, the 7 liberal arts. So we have the 7 liberal arts: grammar, logic, rhetoric, music, arithmetic, geometry, and astronomy. These 4 are the quadrivium, and these are the trivium. But the quadrivium is based on maths, geometry, music, and astronomy, things that can be measured, things that are literally can built into nature, those types of proportions. And that's the Parthenon, or what can it's there. It's, again, many other people have noticed it. Again, I can't post the link because it'll take you directly to open it in Word or whatever you're processing. But yeah, Anne Bulkin's analysis of the proportions of the Parthenon and its meanings. Again, she presented this paper at the Deakin University here in Geelong in Australia, and well, weights and measures built into the Parthenon. You'll find again the same system in the Great Pyramid, stone circles such as Stonehenge, King's Men. These again just repeated all the time, and it's either you can call it coincidence. Or you can say that in the ancient world, they built these temples at these proportions with these measures to deliver and preserve this knowledge. It was done with extraordinary precision, engineering skills. The standard, presentations by the, BBC or whatever are just so. They're not including this stuff. They just don't want to include it. They don't want it to be taught. The 7 liberal arts has been eradicated from the modern education system. With a small set of numbers, you can learn music, astronomy, geometry, and all these things come together. Imagine if young children were introduced to this, how much by the time they even enter high school, how many things they would know. The size of all the heavenly bodies, music theory, lovely maths and geometry, yet we're taught, especially for a new math and this, BS methods. And well, it's I can't see an argument to justify the modern education system as opposed to this method. It just makes things so much easier. By learning one thing, you learn another. Your weakest subject becomes your strongest subject. It's just wonderful. This is why the power of it, and it's just been either diminished in meaning or reduced or mocked by the establishment. And well, I think it's a sin. And so yeah, so that's the okay. Now, for instance, pentatonic tuning. Where we go. So there's, like for instance, the cellar is the inner temple, but it also includes the larger temple, the base, but also the height proportions. What can you, 1440, that's just, well, yeah, okay, there's some, like other stuff, these are all four-dimensional, if you're working in four-dimensionals, dimensions based around binomial theorem, it all comes together. Here's an example of the like pentatonic, that 5-note tuning system, which is built in there, and even, well, is the Egyptian star glyph. Is this one of the things they're pointing out? The Egyptians were, they had their lyre, and they had, it's not written down in a nice, convenient, peer-reviewed ISBN number left on some piece of papyrus, and so therefore it can't be accepted. But by reverse engineering this stuff, by using the measures and the proportions, and it's either it's an extraordinary symphony of coincidences across time, across the world, it's all just an accident, go away, or there is something to this, there is something to be gained from it, and the official version of history, of ancient history that we're taught through most of the mainstream gatekeepers, is just a smoking pile of dung. With that, I'm going to end this video with a little clip from an excellent from the 50s or the 60s by Disney, who Disney understood the importance of the golden ratio, Pythagoreanism. But there's if you can do a search, Donald Duck in Mathemagic Land. I'm going to end with a portion of it in regards to Pythagoras and musical theory. And with that, hope you enjoyed this video. Have a good one, and cheerio.
Journey through the wonderland of mathematics.
Mathematics? That's for eggheads.
Eggheads? Now hold on, Donald. You like music, don't you?
Yep.
Well, without eggheads, there would be no music. Come on. Let's go to ancient Greece, to the time of Pythagoras, the master egghead of them all.
Pythagoras?
The father of mathematics and music.
Mathematics and music?
Ah, you'll find mathematics in the darndest places. Watch. First, we'll need a string. Stretch it good and tight, plunk it. Now divide in half. Plunk again. You see? It's the same tone, one octave higher. Now divide the next section. And the next. Pythagoras discovered the octave had a ratio of 2 to 1. With simple fractions, he got this. And from this harmony in numbers developed the musical scale of today.
By golly, you do find mathematics in the darndest places.
You can imagine how excited Pythagoras was when he shared his findings with his pals, a fraternity of eggheads known as the Pythagoreans. They used to meet in secret to discuss their mathematical discoveries. Only members were allowed to attend. They had a secret emblem, the pentagram. Let's see what the topic is for today.
What's going on?
It's a jam session.
Give me something with a beat.
Shh. So from these eggheads, the Pythagoreans, with their mathematical formula, came the basis of our music of today.